Hello everyone, in today's video we will be seeing this question from the year 2022. In this question we are given a homogeneous right triangular pyramid with a base side A and a height 3a by 2 as you can see in the figure. So here we have to obtain a moment of inertia tensor for this pyramid. This is a 3D structure, so we are going to have a 3 cross 3 matrix. So let's first see the tensor. So here we got two expressions for angular momentum. First is L is equal to I omega and second is L is equal to R cross P. So we can write this cross product L is equal to M R cross omega cross R. So using this R vector and omega vector, we can find this cross product and we get this expression. So we can write this whole expression in the form of matrix. So when we equate these two expressions, we can get this matrix form equation. So on comparing, we get this moment of inertia tensor equal to M, this matrix of y square plus z square minus xy minus xz, and then minus yx, x square plus z square minus yz minus zx minus zy and x square plus y square. So this is our moment of inertia tensor. So now find out the volume for this pyramid. So general formula for finding the volume of pyramid is 1/3 area of base times height. So this is our whole expression. So if we take this base in the plane xy and the height h, so here we know the base is triangle, so we can use the area of triangle half base into height. This is half a into a, and the height is 3a by 2. So we can cancel the 3 and we get 1/4 a cube. So before finding the matrix, let's write the equations for the relation between x, y, and z. X over a, the intercept, y over a, its intercept, and z over 3a by 2, the intercept at z axis, which is equal to 1. This is the equation interrelates x, y, and z. And the equation of lines, that's in xy plane, x over a plus y over a is equal to 1. And on the z and y plane, so y over a and z over 3a by 2 is equal to 1. And similarly for x and z, x over a and z over 3a by 2 is equal to 1. So these are the equations we are going to use in setting the limits for our integrals. So let's find out the elements for the matrix. So starting with the first element, ixx can be written as dm y square plus z square. So dm can be written as rho dv. So where dv, this is the volume element which can be written as dx, dy, and dz in the form of three differentials. Here rho is our density. So let's substitute for the dm in the expression ixx. So ixx is equal to rho, the integral y square plus z square dx, dz, and dy. This is the order of our integration. Using this equation of x over a, y over a, and z over 3a by 2 is equal to 1, we can set the limit for x. So x is equal to a minus y minus 2 over 3 z. So we can set this limit. So our upper limit will be z equal to a minus y 3 over 2. As the last, the limit for y is equal to 0 to a. So these are the limits for the three integrals. So let's start our integration. So let's start. So the integration dx is simply x. So and then dz and dy. So let's put the limit for x. This is a minus y minus 2 over 3z dz dy. So this is our expression during the second integration with respect to z. So before doing so, we will multiply these. So this is our expression after multiplication. So let's do the integration with respect to z. So which is equal to y square a z plus z cube over 3a minus y cube z minus z cube by 3y minus 2 over 3 z square over 2 y square minus 2 over 3 z 4 over 4, and then putting the limits for z 0 to 3 over 2 a minus y, and then dy. So club these two terms, we get z cube over 3a minus y, and then these two terms, so we get y square z a minus y, and write the other two terms. So that's z square over y square over 3 minus z over 4 6. So let's now the limits and then dy. So let's put the limits now. So this will be 27 over 8 and then 3. This is a minus y whole cube and then a minus y, then plus y square plus 3 over 2 a minus y, and then a minus y minus 9 over 4 3 a minus y whole square y square minus 81 over 16 a minus y, then dy. So let's move to the next page. So this is our expression till now. So let's now simplify this expression. Taking the a minus y to the power 4 common, we get 9 over 8, and there's minus 27 over 32. And there's another, taking the common y square, 3 over 2 y square a minus y whole square. So we get 1 minus half. So this dy. So now let's solve this further. So this a minus y to the power 4. So this is 32 and this is 36 minus 27 plus this will become 3 over 2 into half plus 3 over 4 y square a minus y square dy. So now the expression will become a minus y to the power 4 9 over 32 plus 3 over 4 y square a minus y whole square. This bracket and then dy. We take out 3 over 4 common with row. Y equal to 0 to a minus y whole square common, and then 3 over 8 a minus y square plus y square, and then bracket close dy. So opening the whole square, we get this expression. So now let's solve this second bracket, writing the first a square plus y square minus 2ay, and then 3 over 8 a square plus 3 over 8 y square minus 3 over 4 ay plus y square dy. So we can add this 3 by 8 y square plus y square. This will give us 11 over 8 y square. So let's write 3 over 4 row 0 to a square plus y square minus 2ay, and this will be 3 over 8 a square plus 11 over 8 y square minus 3 over 4 ay dy. So let's multiply these two brackets. So this will become 3 over 8 a4 plus 11 by 8 a square y square minus 3 over 4 a cube y plus 3 over 8 a square y square plus 11 over 8 y4, and then minus 3 over 4 a y cube minus 3 over 4 a cube y minus 11 by 4 a y cube minus that will. So now integrate with respect to y. So this is 3 over 8 a4 y plus 11 by 8 a square y cube over 3 minus 3 over 4 a cube y square over 2 plus 3 over 8 a square y cube over 3 plus 11 over 8 y5 over 5 minus 3 over 4 a y4 over 4 minus 3 over 4 a cube y square by 2 minus 11 over 4 a y4 over 4 plus 3 a square y cube by 3. So we get this expression after solving this. So now let's take the a to the power 5 form. We have taken all the terms. So let's solve it. So this gives us 3 over 16 row a5, and this is 13 over 30. So now let's put the expression for density. This is mass. The volume is 1 over 4 a cube, and then a5 13 over 30. So let's cancel a cube with a5. We are left with a square, and this 4 with 16. So we are left with 13 over 40 ma square. So let's move to the next element, ixy, which is equal to minus xy, and then dm. These are the limits, z equals 0 to 3 over 2a minus x minus y, and the y is going from 0 to a minus x, and x is equal to 0 to a. So now let's substitute for dm, which is rho dx dy and dz. So this is minus rho integrals zy and x, this is the order, and this is xy and dz dx. So now let's first do the integration with respect to z. So minus rho x y, these are two integrals. The integration of dz will be z, putting the limits, that is 0 to 3 by 2 a minus x minus y, and then dy and dx. So let's put the limit, minus rho integrals x y 3 over 2 e minus x minus y dy dx. Let's take the 3 by 2 out with rho. So then integrals, then multiply these two terms, axy minus x square y minus xy square, then dy dx. So now let's integrate with respect to y. So this will become a x y square by 2 minus x square y square by 2 minus x y cube over 3, and then putting the limits 0 to a minus x, and then dx. So let's move to the next page. So we are here with this expression. Now let's put the limit for y. So this is minus 3 over 2 rho, and then integral x, so a x over 2, so a minus x whole square minus x square over 2 a minus x whole square, and this minus x over 3 a minus x whole cube. So this is our expression, and then dx. So now to solve it, so we can take x over 2 a minus x whole square common, and then we are left with a minus x and minus x over 3a minus x whole cube, bracket close, and then dx. So minus 3 over 2 rho x equal to 0 to a. So this is x a minus x whole cube over 2 minus x a minus x whole cube over 3 dx. So let's take x a minus x whole cube common. So this is half minus 1 over 3. So this is 1 over 6. So our expression is minus 3 over 2 rho x 0 to a x a minus x whole cube, and we can take the 1 over 6 out, so we can cancel 3 with 6. We are left with minus rho over 4 x 0 to a x a minus x whole cube. We can open this whole cube, which will give us a cube minus x cube minus 3a square x plus 3a x square, and then dx. So let's multiply this x with this whole cube. So we get minus rho over 4 0 to a, and this is a cube x minus x4 minus 3a square x square plus 3a x cube, and then dx. So let's integrate with respect to dx now. So this is a cube x squared by 2 minus x5 over 5 minus 3a square x cube over 3 plus 3a x4 over 4. So 0 to a. So let's put the limits. So minus rho over 4 a5 over 2 minus a5 over 5. So we can cancel these 3. So minus a5 plus 3 over 4 a5. So let's solve it. So we got minus over 4 a to the power 5. This is 1 over 20. So ixy, after putting the row, which is m over 1 over 4 a cube, and then a5 over 4, this 4 will cancel, and this 1 over 20. So we get the ixy equal to 1 over 20 ma square. So this is our second element, ixy. Similarly, you can find the ixz. So let's start with ixz now. So this is our ixz expression. So these, and we set this limits. So now substituting for dm minus rho. These are the three integrals, and then xz, dy, dz, and dx. So this is the order of our integration. So let's start with the integration with respect to y. So this will be y, putting the limits 0 to a minus x minus 2 over 3z, and then dz dx. So let's put the limits. So minus rho xz integrals xz a minus x minus 2 over 3z dz dx. So let's multiply this. So we get ax minus x square z minus 2 over 3 xz square, and then dz dx. So let's now integrate with respect to z. So this is ax z square over 2 minus x square z square over 2 minus 2 over 3 x z cube over 3, and then limits 0 to 3 over 2 a minus x, and then dx. So let's put the limits. Ax over 2 9 over 4 a minus x whole square minus x square over 2 9 over 4 a minus x whole square minus 2 over 9 x 27 over 8 a minus x whole cube. and then dx. So let's move to the next slide now. So this is the expression. So now simplify it. 9 by 8 x a minus x square. We can take this common and we are left with a minus x. And then the second term is 3 over 4 x a minus x whole cube. And then brackets dx. Let's take x a minus x whole cube common. So we are left with 9 over 8 minus 3 over 4 and then dx. So we can solve this. So this is 9 minus 6 over 8, that is 3 over 8. So we can take this 3 over 8 outside with rho. So this ixz is equal to minus 3 over 8 rho integral x0 to a minus x whole cube. So let's open this whole cube. A cube minus x cube plus 3a x square minus 3a square x. So this is dx. So now let's multiply this whole cube term with x. This is 3 by 8 rho x0 to a cube x minus x4 plus 3a x cube minus 3a square x square, then dx. So let's integrate with x now. So this is minus 3 over 8 rho. So this is a cube x square over 2 minus x5 over 5 plus 3a x4 over 4 minus 3a x cube over 3. So we can cancel this 3. So 0 to a. Let's put the limits. So we get minus 3 over 8 rho a5 over 2 minus a5 over 5 plus 3 over 4 a5 minus a5. So let's take this a5 out. So it's half minus 1 over 5 plus 3 over 4 minus 1. So this is minus 3 over 8 rho a5 and then 1 over 20. So let's put for rho now. Minus 3 over 8 mass over volume and then a5 and then 1 over 20. So we can cancel this 4 with 20. So we are left with minus 3 over 40 ma square. So this is our third element. So let's move to the next element, IYZ. So this is expression. We can substitute for dm. So now let's set the limits. X is going from 0 to a minus 5 minus 2 over 3z. And z is going from 0 to 3 over 2 a minus 5. And y is equal to 0 to a. So this IYZ is equal to minus rho the integrals y and z, and this is yz. The integration is x of dx and then dz dy. So let's put the limits of x. So yz is equal to minus rho yz a minus y minus 2 by 3z dz dy. So let's multiply to minus rho yz integrals. So this is a yz and this is y square z and minus 2 over 3 z square y and then dz dy. So let's integrate with respect to z now. This minus rho, this is a z square over 2y minus y square z square over 2 minus 2 over 3 z cube over 3y and then dy. The limits are 0 3 over 2a minus y. First simplify this. Before putting the limits, let's take the z square y by 2 common, and we are left with a minus y, and this is minus 2 over 9 z cube y, and the limits are 0 to 3 by 2a minus y dy. So moving on to the next slide. This is the expression we got till here. So let's put the limits for z. So this will be 9 over 4 and then 2 a minus y whole square y, a minus y minus 2 over 9 y, and 27 over 8 a minus y whole cube. So bracket close and then dy. So this minus rho y is 9 over 8 y a minus y whole cube minus, so we can cancel 9 with 27 and 2 with 8. So we are left with minus 3 over 4 y a minus y whole cube, and the bracket close dy. So minus 3 over 4 rho integral 0 to a. So let's take by a minus y whole cube common. So we are left with 3 over 2 from the first term and minus 1 from the second term, and then dy. So we can write this 3 by 2 minus 1 as half. So this will become minus 3 over 8 if we take half outside with 3 by 4. So this y a minus y whole cube, we can open this. So we get a cube minus y cube plus 3ay square minus 3a square y dy. So we got this after multiplying with y. So now integrate with respect to y, we get a cube y square by 2 minus y5 over 5 plus 3a y4 over 4 minus 3a square y cube by 3, and then 0 to a. So we can cancel 3 with 3. So let's put the limits a5 over 2 minus a5 over 5 plus 3 by 4 a5 minus a5. So it's minus 3 over 8. Take the 8 to the power 5 common. This half minus 1 over 5 plus 3 over 4 minus 1. So after solving this, we get minus 3 over 8 rho a5. This is 1 over 20. So we can substitute for rho now. So this is minus 3 over 8 mass 1 over 4 a cube a5 1 over 20. So we can cancel this 4 with 8. So this will be minus 3 over 40 ma square. So this is our IYZ. So now move to the next element. So the next element is IYY. So this is expression and these are the limits. So now substitute for dm. This is rho integral x z y, and this is x square plus z square dy dz and dx. So now let's first differentiate with respect to y. So it's rho x and z integrals, then x square plus z square, and the integration of dy is y 0 to a minus x minus 2 over 3z, and then dz dx. This rho x and z integrals x square plus z square, and then a minus x minus 2 over 3z dz dx. So let's multiply this. So now integrate with respect to z. So this will be rho x. So the integration is x square az minus x cube z minus 2 over 3 x square z square over 2 plus z cube over 3a minus z cube over 3x minus 2 over 3 z4 over 4. So our IYY will be equal to this. So we can substitute for 3 by 2 and solve it. So we are here with x square a minus x whole square 3 by 2 minus 3 over 4 plus a minus x to the power 4, 9 over 8 minus 27 over 32. So substituting the limits, we get this expression. So you can pause the video and check the steps. So these are the similar steps you can do on your own. So this is our whole simplification and then putting the limits. So we get this and taking the a5 out. So we get this expression. So which results in our 3 over 4 substituting for density mass over 1 over a cube and a5 this is 13 over 120. So we get the 13 over 40 ma square. This is our I/Y. So this is expression for ICZ. So we can substitute for dm now. So we can substitute for dm. There is rho x, y, and z, x square plus y square, dz, dy, and dx. So let's first integrate with respect to z. So this is rho x and y integrals x square plus y square, and this integration of dz is z, 0 to 3 over 2a minus x minus y dy and dx. So let's put the limits for z. So it's rho x y x square plus y square 3 over 2 a minus x minus y and then dy dx. So let's multiply these two and take the 3 by 2 out with rho. So it's 3 by 2 rho xy. So let's do the multiplication ax square minus x cube minus x square y, then plus y square a minus y square x minus y cube, and then dy dx. So it's rho x y. Let's integrate with respect to y now. Ax square y minus x cube y minus x square by 2 plus y cube by 3a minus y cube by 3x minus y4 over 4. So dy, so it's going from 0 to a minus x dx. So let's simplify this first and then put the limits. So this is expression after simplification. Let's put the values now. Let's put the limits. So it's 3 by 2 rho. This will be x square a minus x and then a minus x square over 2 a minus x whole square plus a minus x whole cube over 3 a minus x minus a minus x whole to the power 4 over 4. So we have put the limits and then close the bracket dx. So let's solve this. So 3 over 2 rho integral x 0 to a. So we can take x square a minus x square common from the first two terms. So we are left with 1 minus half plus this we can take a minus x whole to the power 4 common, and this is 1 over 3 minus 1 over 4. This bracket close and then dx. So we get 3 by 2 rho x is equal to 0 to a. So it's x square a minus x whole square over 2 plus 1 over 12 and then a minus x whole to the power 4 dx. So let's take this half common. So we get 3 over 4 rho a minus x whole square common. This is x square plus 1 over 6 a minus x whole square, then dx. So let's open this whole square. So moving on to the next page, when we open this whole square, we will get this expression. So let's add this x square plus 1 over 6x square, which will get us 7 by 6x square. So let's multiply these two terms. So let's first write it. So a square plus x square minus 2ax, 7 over 6x square plus 1 over 6a square minus 1 over 3ax dx. So let's multiply. So Iz is equal to 3 over 4 rho x 0 to a. So multiply this. We will get 7 over 6a square x square plus 1 over 6a4 minus 1 over 3a cube x plus 7 by 6 x4 plus 1 over 6a square x square minus 1 over 3a x cube. Then next is, this is minus 7 over 3a x cube minus 1 over 3a cube x plus 2 over 3 a square x square dx. So let's integrate with respect to x. So we have 3 over 4 rho 7 by 6 a square x cubed by 3 plus 1 over 6 a to the power 4x minus 1 over 3 a cubed x square by 2 plus 7 by 6 x to the power 5 plus 1 over 6 a square x cubed by 3 minus 1 over 3 a x 4 by 4 minus 7 by 3 ax to the power 4 by 4 minus 1 over 3 a cube x square by 2 plus 2 over 3 a square x cube by 3, and then putting the limits 0 to a. So this is the expression we will get after putting the limits. So we will take this a to the power 5 out. So let's solve. This is 7 by 80 plus 1 by 6 minus 1 by 6 plus 7 by 30 plus 1 by minus 1 over 12 minus 7 over 12 minus 1 over 6 plus 2 by 9. So after solving this, we will get 1 over 50. Good for density. So mass over 1 over 4 a cube and a to the power 5 1 over 15. So this 4 will cancel and the 3 will cancel. So let's write the moment of inertia tensor now. So the ix-axis 13 over 40 ma square, ixy is minus 1 over 20 ma square, and then ixz is minus 3 over 40 ma square. So iyx is equal to ixy. So we can write minus 1 over 20 ma square, and then iyy is 13 over 40 ma square. Then yz is minus 3 over 40 ma square, and then izx, which is equal to ixv, so which is equal to minus 3 over 40 ma square, and then izy minus 3 over 40 ma square, and then izz, which is equal to 1 over 5 ma square. So this is our whole moment of inertia tensor for this pyramid. So if you have any doubts related to any of the elements of this matrix, you can in the comment box. And if you find this video helpful, please like, share and subscribe to my channel, and thank you for watching this video.